Okay. Thanks for coming, everyone. Our event is gonna start in 3 minutes. Hi, everyone. Thanks for coming to today's event at Exploring Actuated Interface Design with Dr. Ken Nakagaki. He's an MIT alum and assistant professor at University of UChicago. He's currently running a lab called AxLab at UChicago, exploring about his specialty, which is actuated interface. He's gonna introduce about his lab and his projects today to start with our event. Warmly welcoming our doctor, Professor Ken Nakagaki.
Thank you so much, Hyun, for a great introduction. Excited to be here. I always wanted to come here. So, these events are really great. And I will talk more. We should have more of this, common back and forth because I do art and technologies and, really interested in not only technology, but how, that creates new interactions, new experiences, new expressions. So this is a great starting point for, many different things to come. My name is Ken Nakagaki. I'm an assistant professor in UChicago. Should I turn up? Is it okay? The audio's good? Okay, cool. So I am currently an assistant professor at UChicago in computer science department, but from my undergrad, I always have been in a really interdisciplinary domains or departments where I was studying interaction design, mix of design and engineering from my undergrad, and did master's and PhD at the MIT Media Lab, which is like really interdisciplinary. So kind of like learning to be computer science professors or researchers together with my students and running my own lab named AxLab. I mainly publish papers in human-computer interaction domains, but I care about building new interaction, designing new interaction with new technology. So I hope to share those stuff. So human-computer interaction is basically the domain that we have the crazy Apple Vision Pro coming, but basically pretty much the modern computer interfaces are majorly visually dominant user interfaces that you have this flat screens or some screens that you're wearing on top of it that you will, it's more you look at the interface and you use keyboard or mouse or your, mid-air gesture to interact with these digital interfaces. On the other side, what I really love and care is the quality of the material around us, that the material we grew up with, that squishing clays, feeling the material of the thing on your fingertip, shaping the strings within your hand. I really love the string figures that you can create different shapes. Your subtle movement of the finger really affecting the shape of the material, or this feeling some mechanical toy that I have so many mechanical toys in my office if you come to, but there's so much love of this physical materials and tangible materials, the quality around us in while the computer interface, human-computer interface dominantly is more graphical things, I really care about the physical tangible materials. So lots of my work is not like that, visually dominant interfaces, but really care about this materiality of the objects, especially bringing this shape-changing actuation capability in it. So I do research in human-computer interaction, inventing and designing actual user interface technologies, which I hope to show a lot today. And I was really fortunate to have Professor Hiroshi Ishii as my PhD advisor. And he's the strong visionary researchers who coined or started the tangible user interfaces, which many researchers follow. We have the group, the Tangible Media Group. His group has been working on this vision of radical atoms, which I was fortunate to join in the journey in 2014. Has anyone seen this video before? Some of you, not many, but so this was one of the projects that really, as many of you, it really caught my attention. Really loved it. So it's basically the idea is how to bring this form, physical dynamic form, into digital material, digital information. So I won't talk too much about his Professor Hiroshi's vision, but it's basically about bringing tangible material into the digital user interface design. And I joined the Media Lab in 2014, so I was joining when he was pushing this idea to how to not only make digital information tangible, but how we can bring the material to dance, animate, dynamically shape change and stuff like that. If you're interested in more of the research academic domains, I do publish lots of papers around majorly around shape-changing interfaces. In the radical atoms was a little bit more what Hiroshi was coining it, but I think in terms of the HCI domain, shape-changing interfaces is one thing, very exciting domain for me. So I use the word actuate a lot because this is the term that is, more like an engineering term that to put machines or devices into mechanical action or motion. Being in MIT, even in UChicago, people build these engineering things using motors to make things move. Robots have lots of actuators to make motions and stuff. So, I'm personally excited about building things that shape change and actuate. So that has been my PhD research. But during my PhD, I found in the dictionary that there was actually a secondary definition of the word actuate, which is to move people to take action or motivate people to take action. So, and when I asked like the engineer friend at MIT that time, like no one knew this secondary definition. We thought it is purely like engineering word, but there is this like touch of the human into the word actuate, and which resonated with me a lot. That because I love building new technologies and stuff, but I don't want the technology I built to be just like moving and dancing and people just stand and watch, sit down and watch. So I think the value of this technology is to really bring people into the loop of the interaction. That I think that's also the value of tangible interface, that because of this physicality and materiality of things, people want to use their body, touch, feel. You fidget with all these toys and stuff. So so that I think there is this like a value to explore the duality of the word actuate, where kind of like at my lab we set this open question of how would actuated technology actuate people, which can be defined in a lot of different ways. But we love building new technologies, but we also love to think of what that brings to human, what that brings us be more creative, what that brings us to be more tangible and physical and embodied through our real to shape the future of our human computer interaction or human technology interaction. So that's how I kind of like name my lab, AxLab, which is a short for Actuated Experience Lab. I would talk several different projects, including my work at the time at MIT, and also the work we are doing now at the Media Lab, at the UChicago, and in different themes, how we fuse the actuation into our everyday environment to shape new types of human-computer interaction. One of the thread is, I call it like infusing materiality for actuation, how we can infuse materiality into actually user interface design and interaction. So joining the Media Lab and seeing that massive shape change in display, so that is composed of like linear motors moving up and down, compressed into shape displays. And we had these questions of like, okay, it's cool, you can create different shapes, but can we create how can we go beyond shape? Because our materials around us have, like the clay I was talking about, there's so much rich materiality around our environment. So how we can create not only shape but also material property was like one question we had, and we had this idea to basically utilize the shape changing display we had there, but combined with some simulation. These white pins are all made of plastic, but this is really utilizing these pins are really sensitive for how you're touching, and you can create this new expression, or I almost call it like illusion, that represent different material property that can represent from elasticity to viscosity to flexibility. So you can kind of behave like memory form kind of things, springy feedback, etc. And once you are able to do that, you can kind of represent what's a really interesting application where you are again not just providing only the shape but also through the dynamic shape you can express new material properties that people can feel natural interactions, and you can use this to simulate like some urban design, and it could be some like medical, or children can learn the stiffness of some objects, or medical students can use this for palpations, etc. The interesting thing about this project is that, as I said, we found almost like completely new like illusion of like how people perceive the material property. So again, on the fingertip, it's still like you feel like you're touching a piece of plastic. But this like creating this loop of like making a responsive feedback based on a very simple physics simulation running behind the machine, people started to get this illusion of like perceiving different materiality on top of it. So there are also like other cognitive science research, like a pseudo haptics and stuff like that, where you can hack how people perceive materiality. But that was like a really cool thing for us that, as a research paper, we also like tuned the parameter of this different physics property, and people were able to kind of like rate different material property people felt. That is cool to do some study to get some data, but also we really enjoyed how people interacted with this device. That right, like we didn't really ask how to touch this, just touch and enjoy and let us know, rate how you felt. So, and people went really creative or weird in a way that only not using their hand, but also like some people started to lay down, so kind of like bring a new affordance for how you like touch and feel this. When people are talking about like VR and AR, people build like a haptic glove that you can like touch and feel on your fingertip. But I think the value of this kind of like technology is that it's really up to you. You don't need to wear anything, and you can like lay down. I mean, we were actually lay down on our back for the shape display a few weeks ago, but that's like one value we found beyond just like the numbers and quality of it. Okay. Again, last month or just a month ago, we have also replicated. It was taking 2 years to replicate this, but this is now in Chicago. So please come try it. It's really, the best thing is you really need to touch and try it. It's really fun to interact with it. Anyway, so hope you get a chance to visit us. But then at the Media Lab, at the UChicago AxLab, we have been like extending and exploring this line of work. This is an example to apply this like same concept of having a physics simulation running behind this hardware, but this like tabletop robot. So these robots have like a tiny wheels underneath, so they can move around on top of this like surface. So you can kind of like apply this like virtual gravity, and you can apply force. You can feel, in this case, the wheel can give like force feedback, so you kind of like feel the springs and stuff like that. So we are kind of like applying this like same interaction framework, but for like other types of hardware, where you can kind of like apply this in lots of different like entertainment, or also we kind of like explore some like physics education, how this could be potentially used for like classroom setting where students can like tune. You have this like a graphical interface, you can tune and adjust different parameters to learn how different physics parameters affect different things. But these things are a really cool potential thing that we could extend. So on the line of this materiality, I do really care about this, materiality that we can touch and feel. And during my master's at the Media Lab, another thing I was thinking of was like, okay, these shape-changing devices are really cool, but is there any other new form factor that we could explore? This like tabletop form factor is cool, but it's just staying there. What if we have this like line-based form material, which is like strings. It's like string is a material that I really love playing around with. It's also, if you see the world around us, we see lots of like line-based material like cables, wires. Yes, we go wireless, but still having this like physical, line connecting between devices are still intuitive and nice to have around. So on that line, I built this like new genre or new category of user interface, which I call line form, which is basically a line-based actuated tangible interface for display, interaction, and constraint. Let's me play the video. So the idea is super simple. What if we have a shape-changing line? What if the strings, ropes, wires, those things start to shape-change? How that would change our future interaction with computers, technologies, or materials. And we show lots of different, several different applications, including this mobile device that can like wrap around our wrist, like our smartwatch, but you can give this haptic feedback. And when there's a notification, this thing will stand out. So it gives this affordance to peel this. You need to peel this off. Maybe you get a text input, you transform it to smartphone shape, and once you get a phone call, it transforms into this iconic phone shape that you can make a call. Maybe it's not functionally using a phone, but it's showing how this technology could be adapted to like mobile devices. This is another idea. What if the cable can shape change according to what you connect to? So when you connect to the lamp, the cable would understand it and give this functionality according to what you connected. Cables are also used for representing invisible data. What if you can see some data is stolen, so you can like pinch it instantly? So lots of different application. Explore line is also a really flexible material that you can like wrap around your body like a bandage. So we were exploring how this could be used for like a rehabilitation, for example. It's a bandage that can like change the stiffness according to users' states, and you can also like easily wrap it around as an exoskeleton almost, where you could record some like a professional boxer's movement, and you could replay that on top of your body. Usually exoskeletons need to be designed very specific to people's body size, but what if they become like just like a bandage? You just wrap around your body and become able to get the shape motions and replay on top of it for you to learn some like kinesthetic movement. And I intentionally hide everything under the clothes, but this is basically utilizing some kind of these, robotics technology, specifically like a snake robots, So there are lots of really research, amazing hardware devices or control theory. People try to, mimic the snake locomotions, which is, definitely useful for robot explorations, go through narrow space, and these people really study hard in like these snake robot technology. But one thing I think, the very important thing about this research is kind of like it in a way, it's not technology itself is not super new, but kind of like looking at the same technology from a very different perspective, where it is like, what if we don't see this just as a snake, but what if this becomes everyday material? How can it express information for users, and how it can interact with this? So there are so many interesting, still lots of directions in this line that we are also exploring in AxLab now. Actually, yeah, one type on this line of work of like line-based interface, this Axis, Project Axis is one thing we published last year. So this is basically kind of like looking into this like expandable mechanism of it's a mechanism called scissor mechanism to create this like a where we can have so we call it Axis because it is made of like series of X's, and by switching the pin, it's like a Lego basically. By switching the pin around, we can design like how this thing transforms basically. And by combining with some like really simple motors, you can create this like really cool transformation. And based on the pin configuration, you can basically create really cool, interesting expressions that can, your device transform from one shape to another shape in a really This is like one example application of like game controller my student built, where this is like fishing game. You first need to drive to the fishing point, and once you arrive to the fishing point, this like fishing rod appears, and you throw it, and you catch a fish. This thing extends to the size of the fish you just caught, basically. So kind of like how. Looking at how this thing can, explored in as like a expandable mobile devices that can provide, the tangible feeling into the contents you're interacting with the screens. Another thing I want to show is actually I call it the video prototype. I don't know how many of you are familiar with this approach, but this is the video I'm going to show is a prototype I built even before I built like this, those like snake robot like hardware, which was really important thing for me. So let me play this. So this is a video prototyping method. So I'll talk a little bit more later, but prototyping is a really important part for my research, where by building functional prototype, or by building, this is just like using some stop motion technique, or really simple stop video editing technique to kind of like become a medium that help me to kind of like speculate what new ideas I could generate, or it also becomes a medium for my research group, other colleague, to share what could the future be like. Especially, video prototyping technique is effective that you don't have no constraints from the technology. So you can start more from the vision, then you can like come back to, and still I have no idea how to build this kind of thing, but the idea is that how we can have this like a yarn, a spool of yarn that has this like power of, computational shape changing that adaptively, transform according to people's tangible and gesture input. Cool thing is like a few, maybe 6 years later or 7 years later after that video, I was fortunate to collaborate with some researchers at the Media Lab, led by Ozgun Aspar, where she found or explored this like really thin muscle fiber, which is literally weavable into like everyday clothes and fabric. So I think with the advancement of technology, I got really excited for this because the original vision or the idea I had through that was like really overlaying. So these relationship of like how the vision later come closer with the advanced technology is really exciting. So this line-based interface idea, I think there is so much potential. As I said, some of my students are kind of like looking into this direction, but look at like DNA folding or some art and design sculpture. I really love this like manufacturing thing, wire bending machine that like, it looks like computer graphics, but that is a real-time thing that this thing can shape. So there are lots of like opportunities on this direction to build future line-based interfaces that could be weaved into our everyday life. So that's the materiality research themes anchored around the concept of materiality. Another theme is around environments. How we can think about, not only the material, but our environments as a whole is another topic. So the first project is, I call it Hermit. It is basically, okay, I'll just play the video. That's easier to understand. So I created this, so it's basically using this tabletop as tiny robots that is like really simple cubic shape, but this is, almost like hermit crabs was the inspiration source here, where these, I would say like robotic tangible interface, really simple thing, can like wear different shells that can like override different functionalities. And these things can like wear different shells. I call it like mechanical shells. And these interactive functionality can be translated to other modalities by jointing it. And you can even like combine with something walking shell, for example. And the cooler thing is that you can, multiple of these robots can combine together to move more complex motions. So these are rather simple version, right? 2 robots, 3 robots working together to make more complex motions. But we are also like working on like swarm robot interfaces. What if like 100 robots can work together? It's like a really cool kind of like vision we are thinking. How we can kind of, so it's basically thinking of the future environment where multiple of these universal robots can work with a very simple passive mechanism. I mean, this doesn't look simple, but it's basically everything other than the robots are the passive shells, so which could be like easily 3D printed and assembled by the people. Let's see. And kind of like, we are kind of like looking towards this future of like how we can have a variety of different shells around us, where these tiny robots become like this like support or driving universal device to provide different interactivity. So that's the idea of this hermits. And there's here this one question that these robots are cool that you can like move around on tabletop surface, maybe on the floor, but we are talking about the environment. We have this entire space that we could access to. So the Hermits project was really stuck on the floor. So how can we enrich the entire space instead of only tabletop surface? And the idea is flip the surface. So this was also presented last year with my student in AxLab called AeroRig UI. So in this work, we now deploy these robots onto the ceiling surface using like magnets. So the ceiling has these metal plates basically. We can have embedded magnets into these robots that can also like dynamically control like the reel mechanism, so you can control the string. So you have like full access to the 3D space environments and from the ceiling. Could live up there to support our interaction from above. So that was a project. The full video you can find on our webpage. So that was we presented in last year's CHI, which is one of the top HCI conference. Luckily, we got another paper accepted for the same conference, which we call Throw.io, which was idea by Timmy Lin, now a PhD student at UChicago. So this idea is how we can facilitate throw and catch interaction. So Timmy is like almost like a professional juggler. He can juggle 7 balls at the same time, and we were kind of like thinking using this swarm robot lots of magnets inside, so you will stick on the ceiling and drop, and you can catch it. So this looks a little bit, weird in how you facilitate throw and catch, but throw and catch interaction is really hard problem in like robotics. If you want to do that with robotic arm, you need to track the ball trajectory really well, and you need to estimate where the ball is coming. So this is like a really switching the way to think the throw and catch interaction, enabling with a really kind of relatively simple idea here. So in terms of looking at future environments, we were kind of like exploring how these, actuated technologies, mobile swarm robots can be deployed into our environment, not only floor, but also wall or ceilings, and how this can kind of like enrich our physical environment to provide, different new kind of interaction with the digital technology is one thing we are envisioning and wish to push forward further. And looking into this environment, some new project. We'll be publishing this soon. We are presenting this next week in Ireland with collaboration with MIT's group that does like 3D printing. We worked to make this combine the swarm robots with the 3D printer. So in the Hermits, we had this like shells that was like pre-assembled, or like I was gluing together and assemble things together. But those are really limited to like you only have a set of shells. But what if these robots can drive into this 3D printer and they will just get new shells printed, and because it's 3D printer, you can like print any kind of shape on top of it, and it can kind of like bring to the user. So kind of like looking at how the future of robotics and interactive robotics could be, more flexible, dynamic, thanks to having the 3D printer as a way to, bring the new responsive, on-demand, tangible user interfaces. Where's my cursor? Okay. So I think this, thinking at the future environment is really exciting. How these technology can be fused into everyday environments. Let's say space. This is another example of fusing interactive actuation technology into everyday furniture. It's one of the first projects I did at Media Lab, actually, which kind of like envision how this technology can be part of our future, rather than just new display technology, how it can be kind of like facilitate our everyday life from the morning or office space. I'll show a few more projects and we'll try to wrap up. Some final lines of work I want to show is smart handheld tools. I'm really obsessed with just like the materials around us. I think these tools, physical tools, have a lot of like agency in the human that, it gives lots of control for people, and you'll be able to do very specific tasks depending on what you're gripping. You can feel the materials through it, and you give the power to people through these tools. And I was kind of like thinking of how we can kind of like, leverage the affordance and the functionality of this tool for building a new interfaces. And this was a little bit more, this was my undergrad project during that more, I think almost like my first actuated projects, I would say. Let me. More like an entertainment system. So we built this like rolling pin-based haptic device that would create this pleasant sensation of like squishing any objects, like cans, empty cans, or clays. It's really fun it's a pleasant feeling to squish these things. So I wanted to make a device that you can squish any objects. So we came up with this rolling pin device that it looks like a 2D screen, but you feel the 3D shape by rolling this thing. And by combining some 3D printing and some motors, we can achieve this really interesting sensations to create the haptic and embodied experience to squish everyday objects. And we did lots of exhibition for this project where people can come in, children enjoy this a lot. And they can 3D scan this object, and this will be incorporated, scanned into the screen. It looks like it's a screen, but you can feel the 3D shape on it. And once you apply the force, you basically see the objects being stretched, and it will go gradually flatten in terms of the haptic feedback. And at the end, we print out the thing and say, "Oh, you flattened this. Congratulations." I don't know. Yeah. Anyway, so that was really this strong metaphor of the rolling pin, which is a tool everyone knows. Really, make the interaction really intuitive, easy to understand, and enjoy the interactions. Another tool-based device or research was this compass, which I had this idea of drawing complex shape in the real world is really hard, but in the screen it's only drag and drop to draw different shapes. And I had this idea: what if a compass, which is, if you think about it, it's a really cool tool. Only by rotating you get the really perfect circle. What if the compass can draw different shapes as you rotate it? I was also really interested in what does it feel like when you rotate this and you get the square. Does it feel like you drew it, or does the computer do it? Well, basically there's a motor inside this thing to create this shape, and as you input different data, you can draw lots of different things. And again, you can find all these things in my webpage. Okay, so that's a little bit about the materiality. So we went to environment and to the tools. So I'm very interested in looking at the physical environment, how we can fuse these new technologies into what we are familiar with, and harnessing what we are kind of used to, what we love in the environment. That's because I care about. So I started with asking this question of how would actuate technology actuate people, and as I mentioned, that this could be answered or approached lots of different angles, which our lab is still young, so I hope more instances would come out to explore how this thing affects people's creativity, people's behavior, our perceptions, engagement, etc. But I think one most important question is what actuates you is the question that I ask my students, and not all of them like this question, but I think what you really care about and what you really, let's say, love, what you're passionate about is definitely something really important I care about when I work with my students. For me, prototyping process is a very important part. That is something that drives me, that drives my research. That's how I drive my research, but this process itself drives me because I get really, come up with new ideas, you try it, and that made me think new ideas towards the future, and that also becomes an important role to share with other colleague, team members or lab members. So what I presented today is, all made of really dirty Lego or really weird prototypes to build all these things. But these moments, I'm trying to find the very impactful idea or something I have never seen out there, so that I can bring this to impact the world. Either that's a research community or design or art, and etc. And the most important thing is, so that's me with the prototype in my hand. And I think these prototypes are not only the thing that matters. Prototype matters a lot for me, but also, this is a really important medium, or almost like a torch or the lens for us as a researcher or designer or artist to see the future, or what could be possible, what these prototypes becomes, help illuminate the future. So, building the prototypes, but, I also want to let them limit us imagining. So that's like a really, important, relationship between myself and the prototype and how I'm driven by that. And the important thing about these prototypes is once you have some objects, I should have brought some prototype with me today, but I can share with you, and you can try it. Other people can try it. People from different disciplines, computer science, design, art, engineers can try, and they can see different kind of future on top of it. So I think I really I care about bringing how these prototypes emerge new ideas and inspiration for other people too. So in that sense, I while publishing research papers, I do enjoy doing lots of exhibitions and demos. And have anyone been to Ars Electronica before? No, really? Okay, 1, 2. Okay, cool. So Ars Electronica is basically one of the top venue, or the biggest venue, I would say, of art and technology. So it was one of my dreams to bring, my whole lab, not whole lab, but part of my lab went there because we had some paper deadline coming up, but, to bring our work there. So let me play the video of this. So yeah, as you can kind of see that these projects are basically, emerging from my research projects, which we published in a paper. But essentially, one thing I really believe is that research papers only capture one value of the idea, and I think there's something intrinsically kind of inspiring me or make me excited, which is not just a practical research paper that you claim in the paper. But so for me, it's really great to have this kind of other side of how the technology would be able to create new expressions, interactions, and stuff through exhibitions and interaction. And this is also something we just submitted art paper yesterday. So this was just made last night by my students. Yeah. So one thing I want to announce is that I need to publish this officially, but we are working on this exhibition named AxLab, AxLab. So this is going to happen end of this month at UChicago, where it won't be just art projects, but we are planning to, this exhibition basically is where we started last year. I say annual showcase. Both my latest research or ongoing project, even the early weird, I won't say ugly, but chunky prototype, and also my class students would exhibit. So there will be 30 interactive demo. Hope you can come and make it. I will share the info to Hyun, and you can announce with the SAIC community. So I hope many of you can come. And yeah, I would like to end with acknowledging all my students in AxLab who helped this happen, and also lots of the collaborators from MIT and from Japan and Sony, etc. And happy to take question, critique, or have a conversation. Thank you so much.
Thank you so much for the introduction about AxLab. The pieces there are absolutely mind-blowing. We would like to receive some open critiques about the pieces that he just showed, and then to see how our artists and designer communities think, what kind of possibilities that we see from these pieces, and the possibility of the potential values that we can bring in as a collaborator with these technical actuated interfaces and with artists and designers. If you have any opinions about these topics, then please feel free to raise your hand. I can bring the mic to you.
Thank you.
Can you explain about your name and
My
the
name
major?
and my major? Sure. Yes. Hey, thank you, Dr. Kim, for the present. Very nice, about the experiment, and also